In the heart of our galaxy beats an invisible monster. This audiobook takes you to one of the most extreme places in the universe, the galactic core of the Milky Way. There, a supermassive black hole drags stars at impossible speeds, distorts space and makes time twist. What secrets does this bright and chaotic center hide? And what does it reveal about the origins and destiny of the galaxy we inhabit? A journey into the abyss right at the center of it all. When thinking of our galaxy, it's easy to imagine it as a vast collection of stars, but the core is where the magic happens. This core is not just a point in space, it is a hotbed of activity, a place where gravity and matter interact in ways that challenge our understanding. At the center of the Milky Way resides a supermassive black hole, a cosmic monster that attracts everything that comes too close. But how can we know what happens in such a distant and dark region? Astronomers use various tools and scientific ingenuity to study the galactic core. By using telescopes of different types, such as X-ray and radio telescopes, they can examine the radiation emitted from this area. Each flash of light and every wave they capture tells us a story about what is happening there. Thus, they become detectives of the cosmos, gathering clues that help us understand the secrets of the core. The importance of the galactic core goes beyond what meets the eye. This central point of the galaxy acts as a cosmic laboratory where stars are formed and destroyed, where radiation explosions can influence the interstellar medium. But why should we care? The answer is simple. By understanding the core, we can unravel the history of our galaxy and, by extension, the origin of the universe itself. Imagine a great river flowing through a vast landscape. This river represents gravity, and the galactic core is like a reservoir that concentrates all that energy. As the water accumulates, whirlpools and currents are generated. Similarly, in the galactic core, the interaction of matter and gravity creates a dynamic environment that shapes the Milky Way. Without this understanding, it would be like observing the river without understanding its course, unable to predict its floods or droughts. But what about dark matter? This invisible component plays a crucial role in the structure of the galactic core. Although we cannot see it directly, its presence is felt through its influence on visible matter. Imagine that there is a hidden force shaping everything we know. Dark matter is that force, an essential ingredient for the stability and formation of our galaxy. Focusing on the supermassive black hole, Sagittarius A*, we encounter a fascinating entity. This colossus is not only a star-eater, but also acts as a regulator of the behavior of stars in its environment. The gravity it exerts is so intense that it influences the trajectory of the stars orbiting around it. But what does this mean for life in the Milky Way? The answer lies in how these interactions can generate new stars and planetary systems, some of which could harbor life. As we delve deeper into the galactic core, we discover that it is not a desolate place. On the contrary, it is a hotbed of stellar activity. Stars are not only born there, but they also move and cluster, creating a dynamic spectacle. Gravity acts as a conductor, coordinating the movements of these celestial bodies. But what drives these movements? It is a game of forces that reveals the cosmic dance of the Milky Way. The formation of stars in the core is an astonishing process. When matter gathers and collapses under its own gravity, new stars are born. This process is not instantaneous. It requires time and suitable conditions. In the chaotic environment of the galactic core, gas and dust turn into stars, and it is this life cycle that determines the evolution of our galaxy. What other secrets might these newborn stars reveal about the past of the Milky Way? As we explore the core, we also encounter a variety of radiations. From X-rays to radio waves, each type of radiation offers us a window into the phenomena occurring there. Astronomers are like musicians tuning different instruments to create a symphony of data. Every discovery they make illuminates a different aspect of the galactic core and its influence on the cosmos. Relativistic jets are another fascinating phenomenon emanating from Sagittarius A*. These enormous streams of particles are like high-pressure water jets bursting from a hose. However, instead of water, They are particles traveling at speeds close to the speed of light. These jets are not only impressive for their speed, but they also have an impact on the interstellar medium, shaping the galactic environment in ways we are still trying to understand. The intense radiation emanating from the core is not only fascinating, but also has effects on the interstellar medium. This radiation can heat the surrounding gas and dust, affecting how and where new stars form. This process is akin to how the heat from a campfire can influence the growth of plants around it. Without the energy from the galactic core, the formation of new stars could be very different. As we progress on our journey through the galactic core, we find star clusters that are remnants of the Milky Way's past history. These globular clusters are like time capsules containing information about the formation and evolution of our galaxy. Each cluster has its own story to tell, and by studying them, we can unravel the secrets of the cosmic past. And what about the history of our galaxy? The Milky Way has undergone numerous transformations over billions of years. From its formation to interactions with other galaxies, each event has left its mark on the core. This journey through time helps us understand not only the present, but also the future of our galaxy. In summary, the galactic core is a place where matter, energy, and time intertwine. It invites us to explore its secrets and reflect on our own existence in the vast cosmos. By studying this region, we not only obtain answers, but also confront new questions that push us to seek beyond the known. The story of the galactic core is ultimately the story of the Milky Way and all of us. What discoveries await us in the future? The answer lies in the sky, ready to be uncovered. The Milky Way, our cosmic home, is a vast and enigmatic place that has captivated the imagination of humanity since time immemorial. But what exactly is the Milky Way? One can think of it as a gigantic rotating disk of stars, gas and dust, where each component plays a crucial role in the history and dynamics of the universe. As we delve into its structure, we encounter a series of fascinating features that make it unique. One of the most visible features of the Milky Way is its spiral arms. Imagine a bicycle with spokes in the wheel. Those spokes are similar to the spiral arms of our galaxy, where stars cluster in a way that forms a pattern resembling a spiral. In these arms, the density of stars is higher, meaning this is where many new stars are formed. But why do they form in the arms and not in other parts? The answer lies in the interaction of gas and dust found in these areas, which collapse under gravity to give rise to new stars. In addition to the spiral arms, the Milky Way has a halo surrounding it, like a bubble of gas and dark matter that extends far beyond the visible stars. This halo is crucial because it contains dark matter that, although we cannot see it, plays a fundamental role in the stability of the galaxy. Dark matter acts like an invisible glue, holding the stars together and preventing them from dispersing into space. Without it, the structure of the Milky Way could collapse. The galactic disk, where most of the stars and gas are located, is another essential part of the Milky Way. It is in this disk where most of the stellar activity occurs, including the formation of new stars and the death of others. Have you ever wondered how stars behave in this disk? They move in orbits that are the result of the gravitational force exerted by the mass of the galaxy. In this sense, the galactic disk is like a large dance floor where each star follows its own choreography, influenced by the others. The components of the Milky Way are not distributed evenly. At the center, we find a bulge of bright old stars that cluster in a denser region. This bulge is a fascinating place, full of stellar history where stars have been spinning and merging for billions of years. This concentration of stars also suggests that at its core there exists an extraordinary gravitational force that attracts everything around it. As we explore beyond the bulge, we encounter the halo, which not only contains dark matter but also globular clusters. These clusters are groups of very old stars that have survived through the ages. Why are they so important? They help us understand how our galaxy formed and evolved over time. Each cluster tells a story of what happened in the Milky Way billions of years ago, before many of the stars we see today were formed. The The study of the Milky Way not only offers us a glimpse of our place in the universe, but also raises intriguing questions. Why do the spiral arms have that particular shape? What role does dark matter play in the formation of new stars? As astronomers continue to investigate, more questions arise, reflecting the complexity and beauty of our galaxy. The Milky Way is a place where history, dynamics and physics intertwine in astonishing ways. Through telescopes and observations, scientists attempt to unravel the secrets of its structure and functioning. Each new discovery brings us one step closer to understanding how it formed and how it will continue to evolve in the future. But not everything is static in the Milky Way. The galaxy is in constant motion, interacting with other galaxies in its cosmic neighborhood. Over billions of years, it has experienced collisions and mergers that have shaped its form and content. Each of these interactions is another piece of the puzzle that helps us understand the history of our galaxy. As we delve into the heart of the Milky Way, we encounter a complex and dynamic environment. The gravitational forces acting in the galactic core are immense and affect the behavior of the stars orbiting around it. Each star is like a dance in a grand ballroom where gravitational attraction determines the rhythm and direction of its movements. The Milky Way is not just our galaxy, it is a microcosm of what occurs in the universe. Through its study, we can gain insights into how galaxies form, how they interact, and how the cosmos as a whole evolves. The more we learn about the Milky Way, the more we understand about the universe we inhabit. In summary, the Milky Way is a fascinating place full of mystery and beauty, from its spiral arms to its central bulge. Each component has a function and a story to tell. By exploring its structure, we not only delve into the history of our galaxy, but also connect with the vast and infinite universe that surrounds us. Humanity's curiosity to understand its place in the cosmos drives us to continue investigating and discovering new wonders on the journey toward astronomical knowledge. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The galactic nucleus is like the pulsing heart of the Milky Way, a fascinating place where cosmic forces intertwine in a dance of energy and matter. But what exactly is the galactic nucleus? In simple terms, it is the central region of a galaxy where a large amount of matter and energy is concentrated. One could think of it as the engine that drives the dynamics of the entire galaxy, similar to how the nucleus of an atom is fundamental to its structure and function. Most galaxies, including the Milky Way, have a nucleus characterized by a very high density of stars and other celestial bodies. This concentration of stars is comparable to a bustling market in a city, where each star, each gas, and each cosmic dust interact with one another, generating a vibrant and complex environment. But why is it so important to study this region? The answer lies in the crucial role that the nucleus plays in the evolution of the galaxy. Just as the core of a volcano can influence lava eruptions on the surface, the galactic nucleus affects the formation and movement of stars throughout the rest of the galaxy. Furthermore, studying the nucleus provides us with clues about the history and future of our galaxy. By delving into its nature, we can understand how the Milky Way formed and how it will behave over time. One of the most intriguing features of the nucleus is its complexity. It is not just a group of stacked stars, but a highly dynamic system where gravitational forces are extremely strong. Imagine a large whirlpool where each star spins and moves in a gravitational dance, being attracted to one another while orbiting around the center. In the case of the Milky Way, at the heart of this whirlpool lies a supermassive black hole that acts like the core of an apple, keeping everything in place. But how do stars behave in this region? In the galactic nucleus, stars are not only closer to each other, but they also move at impressive speeds. This is because gravitational attraction is much stronger at the center than at the edges of the galaxy. Just as balls on a skating rink accelerate as they approach the center, stars in the galactic nucleus move rapidly, creating a spectacle of cosmic motion. In addition to stars, the nucleus also harbors a large amount of gas and dust. This material is essential as it is the basic component for the formation of new stars. In the nucleus, where temperatures and pressures are extreme, this gas clumps together and condenses into new stars, which in turn fuels the activity of the nucleus. It's as if in a kitchen the ingredients are mixed and simmered to create a delicious dish. However, life in the galactic nucleus is not just about star formation. The intense gravity and radiation emitted by the supermassive black hole can create a hostile environment. Imagine a battlefield where the pressure and heat are so overwhelming that only the most resilient stars can survive. This extreme environment affects not only the stars but also the surrounding gas and dust, shaping the structure of the nucleus. As we explore the galactic nucleus, we also encounter a fascinating phenomenon: relativistic jets. These streams of matter are expelled at speeds close to the speed of light, creating jets of particles that shoot out into space. It's as if the nucleus is exhaling energy and matter in a powerful explosion, affecting everything around it. These jets are not only a visual spectacle, they also have a significant impact on the evolution of the interstellar medium. Studying the galactic nucleus leads us to reflect on our own questions about the universe. What secrets does this place hold? How do interactions influence its surroundings? As astronomers investigate, they face intriguing mysteries that remain unanswered. The dynamics of the galactic nucleus is a constantly evolving puzzle, and each new discovery adds a piece to this complex picture. The importance of the galactic nucleus extends beyond the borders of our own galaxy. By comparing the nucleus of the Milky Way with that of other galaxies, we can gain valuable insights into how galaxies form and evolve in the universe. Each galaxy has its own story, and by studying ours, we can unravel patterns that repeat across the cosmos. The galactic nucleus is, in essence, a microcosm of the Milky Way. Each star, each gas, and each interaction tells a story about the formation and evolution of our galaxy. By understanding this region, we not only learn about the Milky Way, but also about the universe as a whole. Thus, the study of the galactic nucleus becomes a window into the mysteries of the cosmos, challenging us to continue exploring and discovering. Ultimately, the galactic nucleus is a reminder that the universe is a dynamic and vibrant place. Although it is far removed from our everyday experience, its study connects us with the fundamental processes that shape everything we know. With each new discovery, we come closer to understanding not only our galaxy, but also our place in the vast universe. Dark matter is one of the great mysteries of the universe, but what exactly is it, and why is it so crucial for understanding the galactic core of our Milky Way? To begin with, dark matter is a form of matter that neither emits, reflects nor absorbs light, making it invisible and undetectable with conventional telescopes. However, its existence is inferred from the gravitational effects it exerts on visible matter. It's like a ghost that, even though you can't see it, you know it's there because you feel its presence. Imagine you are in a dark park. Even though you can't see the people around you, you sense that there is something else in the air. Similarly, astronomers have detected that most of the mass of the Milky Way is composed of this dark matter. This is fundamental because without it, we couldn't explain why stars and galaxies rotate at the speeds they do. Dark matter acts like an invisible skeleton that holds the galaxy together. Now, how does all this relate to the galactic core? The core of the Milky Way is a place where the density of matter and energy is extremely high. Here, dark matter plays an essential role in the stability of this region. Imagine that the galactic core is like the center of a whirlpool. Dark matter acts as a stabilizer, allowing stars and other objects to remain in orbit despite the intense gravitational forces at play. As we delve into the core, the influence of dark matter becomes more evident. Without it, the stars closest to the galactic center wouldn't have enough gravity to stay together. This means that the supermassive black hole at the heart of our galaxy, known as Sagittarius A*, might not have the same influence if dark matter were not present. Essentially, we could say that dark matter is the glue that keeps everything together in this chaotic region. But why is it so difficult to detect? Dark matter does not interact with light or ordinary matter, which means we cannot see it directly. Scientists have developed various theories to try to understand its nature. Some suggest it could be composed of yet undiscovered particles, while others believe it might be a form of dark energy. Dark matter is also related to the formation of large-scale structures in the universe. Imagine throwing a handful of sand into the air. As the sand falls, it groups into piles due to gravitational forces. Similarly, dark matter contributed to the formation of galaxies, acting as a scaffolding that attracted visible matter toward it. Without this attraction, galaxies, including the galactic core, would not have been able to form as we know them today. In the context of the galactic core, dark matter not only influences the dynamics of stars, but also affects how they are distributed. Computer simulations have shown that, in the presence of dark matter, galactic cores tend to be denser and more compact. This means there are more stars in a smaller space, something that is observed at the center of our galaxy. The importance of dark matter is not limited to the Milky Way. By observing other galaxies, astronomers have found similar patterns, suggesting that dark matter is a universal component in the cosmos. This raises fascinating questions. Could dark matter be the key to understanding the formation of the universe itself? Each new observation brings us one step closer to solving this enigma. However, despite the advances, many questions remain. Why have we not detected dark matter particles in laboratory experiments? What does this mean for our understanding of physics? These questions take us to the frontier of human knowledge and invite us to explore beyond what we know. Dark matter also has implications for the future of the Milky Way. As our galaxy and others merge and evolve, dark matter will continue to play a crucial role in how these interactions develop. In a sense, it is the invisible thread that connects all galaxies in the vast tapestry of the universe. In conclusion, although dark matter remains a mystery, its influence is undeniable. By studying how it interacts with the galactic core, we are not only learning about our own galaxy, but also about the universe as a whole. With each discovery, we get a little closer to unraveling this cosmic enigma, and who knows what surprises the future holds for us. The search for dark matter is a journey that has only just begun and will surely take us to unexpected places in the vast universe. At the heart of our Milky Way lies a fascinating object that has intrigued astronomers and space enthusiasts alike, the supermassive black hole known as Sagittarius A*. But what exactly is a supermassive black hole? And why is it so important for our understanding of the galaxy? Let's dive into this cosmic mystery. To begin with, imagine a huge funnel in space, a place where gravity is so intense that nothing can escape its pull. Not even light. That is, in essence, what a black hole is. But when we talk about a supermassive black hole, we are referring to something even more extraordinary. These cosmic giants can have millions or even billions of times the mass of our Sun. How is it possible for something so massive to form at the center of a galaxy? The formation of these black holes is a topic of intense research. They are thought to arise from the collapse of massive stars at the end of their life. As these stars consume their fuel, they sink under their own gravity, creating a black hole. However, in the case of supermassive black holes, the process is much more complex. They may have grown from smaller black holes, merging with others and accumulating matter around them. It's like a snowball growing as it rolls down a slope. Now let's consider the influence of Sagittarius A* on its surroundings. This black hole is not alone. It is surrounded by a dense cluster of stars and gas. The gravity of Sagittarius A* is so powerful that it affects the trajectory of these stars, causing them to move rapidly around it. Imagine a group of dancers on a dance floor, where one of them has an invisible magnet pulling them toward its center. That is the cosmic dance happening in our galactic core. But what happens if a star gets too close to Sagittarius A*? The gravity of the black hole is so intense that it can tear the star apart, a process known as tidal disruption. This occurs when the gravitational force is stronger on one side of the star than on the other, causing it to stretch and ultimately disintegrate. It's an impressive and terrifying spectacle at the same time. Can you imagine being part of that star? In addition to influencing nearby stars, Sagittarius A* also plays a crucial role in the overall dynamics of the Milky Way. Its immense gravity helps maintain the structure of the galaxy, acting as an anchor at the center that keeps everything in place. Without this black hole, the Milky Way might not have the same shape or stability. It's like the hub of a wheel that allows everything to spin in harmony. But the influence of Sagittarius A* is not limited to its gravity. This black hole can also emit radiation, especially when it is eating matter. As gas and dust fall toward it, they heat up and emit radiation in the form of light, X-rays, and other forms of energy. This radiation allows astronomers to study the black hole and its surroundings, even when it is hidden behind large clouds of gas and dust. Research on Sagittarius A* has also provided clues about the nature of dark matter, that mysterious substance that makes up much of the universe but that we cannot see. The way stars move around Sagittarius A* helps scientists infer the amount of dark matter present in the galaxy. Undoubtedly, the black hole has become an important benchmark in our quest to understand the cosmos. However, there is still much more to discover about these cosmic giants. For example, supermassive black holes may impact the formation of new stars. The intense gravity and radiation they emit can affect the surrounding gas and dust, creating conditions that could either foster or inhibit star formation. It's a delicate balance that remains a subject of research. As astronomers continue to explore the galactic core, intriguing questions also arise. What would happen if Sagittarius A* began to consume more matter than usual? Could this trigger a burst of star formation or, conversely, destabilize the galaxy? The answers to these questions are fundamental to understanding not only our own galaxy, but also how other galaxies function in the universe. With each new discovery about Sagittarius A*, our understanding of the universe expands. As we observe the behavior of stars in the galactic core and how they interact with the black hole, we come closer to unraveling the mysteries surrounding not only our galaxy but also the very nature of gravity and space-time. In summary, the supermassive black hole at the center of the Milky Way, Sagittarius A*, is not just a fascinating object in space but a key element in the structure and dynamics of our galaxy. As science advances, each new finding brings us one step closer to understanding the role it plays in the history and future of the Milky Way, as well as in the vast universe that surrounds us. In the heart of the Milky Way, the stars in the galactic core behave in a fascinating and often surprising way. But what makes this small corner of the universe so special in terms of stellar dynamics? The answer lies in the way these stars interact with each other and their environment, creating a cosmic ballet that challenges our understanding. The stars in the galactic core are not like those found in the spiral arms of the galaxy. Here, the density is much higher, meaning that the stars are much closer to one another. This compact environment leads to more frequent interactions and consequently a variety of movements that are truly extraordinary. How does this affect their evolution? As stars come closer together, they can experience what is known as gravitational interactions. These interactions can alter their orbits and in some cases even lead to one star stealing material from another. Imagine a dance where the stars glide and spin, sometimes getting too close and causing an explosion of energy. The movement of stars in the core is not just a visual spectacle, it is also dictated by the powerful gravitational influence of the supermassive black hole at the center. This dark giant acts like a magnet, drawing stars toward it and affecting their trajectories. But what happens when a star gets too close to this colossus? The answer is fascinating. Some stars can be torn apart by the tidal forces of the black hole, while others may be absorbed, feeding its voracious appetite. Thus, the black hole not only shapes the structure of the core, but is also a key player in the story of every star that finds itself nearby. The distribution of stars in the core is not random. Astronomers have observed that there are more young, bright stars in this central region than in other parts of the galaxy. Why does this happen? The answer lies in the large amount of gas and dust found in the core. This material clumps together and collapses, forming new stars in a continuous process that resembles a stellar birth cycle. In this sense, the galactic core can be considered a nursery for stars, where they form and evolve in a highly dynamic environment. In addition to young stars, there are also many old stars that inhabit the core. These stars, which have lived long and complex lives, have stories to tell. By studying their characteristics, astronomers can glean clues about the evolution of the galactic core and its history. What secrets do these old stars hold? Their chemical composition, for example, can reveal information about the first generations of stars that existed in our galaxy. The galactic core is also home to dense star clusters, where stars are grouped in a relatively small space. These clusters act as natural laboratories for studying stellar dynamics. In a cluster, stars can interact in ways that are not seen in other parts of the galaxy, allowing scientists to observe phenomena such as stellar mergers or the migration of stars toward the center of the cluster. Isn't it amazing to think that in these small spaces, so many mysteries about the life of stars can be uncovered? The speed at which stars move in the core is also noteworthy. The stars closest to the supermassive black hole can travel at extraordinary speeds, even thousands of kilometers per hour. This speed is not just a curiosity. It also helps astronomers measure the mass of the black hole. The faster the stars move, the more massive the object that attracts them must be. This means that studying stellar motion in the galactic core provides crucial information about the nature of the black hole at the center of the Milky Way. Studies of stellar dynamics in the galactic core have also revealed that many of these stars have elliptical orbits. This type of orbit suggests that the stars are subject to influences from multiple bodies, further complicating their behavior. In this environment, each star is part of a larger system and is constantly interacting with other stars and the black hole. How is stability maintained amid this chaotic dance? That is one of the questions astronomers seek to answer. As we delve into this fascinating world, it is important to consider the impact that the evolution of the galactic core has on the Milky Way as a whole. The interactions between stars, mergers, and the influence of the black hole not only affect individual stars but can also have repercussions on the formation of new structures within the galaxy. Could the dynamics of the core be responsible for the creation of new spiral arms in the future? This is an active area of research in modern astronomy. The importance of studying stars in the galactic core also extends to the search for life in other systems. Understanding how stars form and evolve in extreme environments can provide clues about the habitability of other planets orbiting these stars. Could there be worlds in these dense stellar systems that harbor life? Exploring this possibility is one of the many exciting paths that arise from analyzing stellar dynamics in the heart of our galaxy. As we reflect on what we have learned about the stars in the galactic core, it is evident that this small corner of the universe is a microcosm of activity and change. Each star, each interaction, and each movement tells a story that helps us better understand the Milky Way and, by extension, the cosmos. The galactic core is not just a place filled with stars. It is a cosmic laboratory where fundamental processes shape the galaxy as a whole. So the next time you look up at the night sky and see the stars, remember that at the heart of our galaxy lies a place where the dance of these lights is much more intense and complex than we can imagine. The stars in the galactic core, with their dynamic movement and interaction, invite us to keep exploring, to delve into the mysteries of the universe and to better understand our place within it. In the heart of our galaxy, the galactic core presents itself as a bustling hive of stellar activity. But how do stars form in this enigmatic region? To understand this, we must first know the unique environment surrounding the galactic core. Imagine a vast ocean of gas and dust where gravitational forces play a crucial role. This ocean, filled with the elements necessary for star creation, is the starting point of it all. Stars are born from dense clouds of gas, known as nebulae. These nebulae are like large sponges that absorb matter from the surrounding space. As the gas accumulates, gravity begins to work its magic. But what triggers this accumulation? The answer lies in disturbances, which can be caused by the interaction of nearby stars, supernovae, or even the supermassive black hole residing at the center of the Milky Way. When one of these disturbances occurs, shockwaves are generated that compress the gas clouds. This process is similar to squeezing a balloon. By applying pressure at one point, the air accumulates in one section, increasing density. In the case of interstellar gas, this compression causes temperatures to rise, leading to increased molecular activity. In this environment, hydrogen and helium atoms begin to fuse, forming what are known as protostars. Protostars are like the babies of the universe in their initial stage of development. As more matter accumulates, the temperature and pressure in their core increase. When conditions are right, nuclear fusion begins, a process that converts hydrogen into helium and releases a tremendous amount of energy. This is the moment when a star is born, illuminating its surroundings and simultaneously influencing its neighborhood. Star formation in the galactic core is not an isolated process. Newly born stars interact with their environment, creating currents of gas and dust that can lead to the formation of new stars. This phenomenon is like a chain reaction. One star being born can trigger the formation of others, creating a cycle of stellar birth that can last millions of years. In the galactic core, where the density of matter is high, these interactions are even more frequent. However, life is not easy for these young stars. In the galactic core, competition for resources is fierce. What happens when several stars try to form at the same time in such a confined space? A constant struggle for matter ensues. Some stars manage to grow and shine, while others may be absorbed by the gravity of their companions or even by the central black hole, which acts as a voracious devourer of matter. Another fascinating aspect is the influence of the supermassive black hole, Sagittarius (*). Its gravity not only affects the stars that are closest, but can also alter the trajectories of gas clouds that are at a considerable distance. This gravitational pull can cause these clouds to move toward the core, facilitating the formation of new stars. It's as if the black hole is a conductor, directing the movement of each component in this complex stellar symphony. The radiation emitted by stars also plays a role in star formation. As stars are born and evolve, they emit light and energy that heats the surrounding gas. This radiation can, in turn, affect adjacent clouds, causing them to collapse and form new stars. Thus, there is a constant dialogue between stars and gas, a dynamic exchange that perpetuates the cycle of star formation. However, not all stars in the galactic core share the same fate. Some become red giants before exploding as supernovae, scattering their materials across space. This material, rich in heavy elements, is essential for the creation of new stars and planets. In this sense, each star that dies contributes to the rebirth of new generations of stars, creating a life cycle that seems endless. As stars cluster in the galactic core, star clusters also form. These clusters are like small communities of stars that share a common origin. Their study is vital for understanding the history of the galactic core, as they can provide clues about the conditions that prevailed at the time of their formation. The diversity of clusters in the galactic core reflects the rich and complex history of our galaxy. Star formation in the galactic core is not only a fascinating phenomenon but also fundamental to understanding the evolution of the Milky Way. As new stars are born and others die, the galactic ecosystem is constantly transforming. The energy and elements released during this process are the very foundation of life itself, leading us to wonder, how does this influence our own existence? The story of star formation in the galactic core is a tale of creation and destruction, an endless cycle that has taken place over billions of years. Every star that shines in the night sky is a testament to this process. reminding us that in the vast universe we are part of a much larger story. Exploring the galactic core helps us understand not only our home, the Milky Way, but also our place in the cosmos. The emission of radiation in the galactic core is one of the most fascinating and enigmatic phenomena that astronomers have studied. Did you know that the center of the Milky Way is a place where different forms of radiation are produced, each with its own story and characteristics? This radiation provides us with clues about the processes occurring in this dense and active region of the cosmos. First, let's consider radio wave radiation. This is like a kind of language that allows scientists to communicate with the universe. The radio waves emanating from the galactic core are generated by electrons that, as they move through magnetic fields, emit this form of energy. Just as a flashlight can illuminate the darkness, these radio waves shed light on the mysteries surrounding Sagittarius asterisk, the supermassive black hole at the center of our galaxy. But radio waves are not the only important type of radiation. There is also infrared radiation, which is essentially light that we cannot see with the naked eye. Imagine a warm summer day. Although you cannot see the heat of the sun, you can feel it. In the same way, infrared radiation allows us to observe the heat emanating from stars and hot gas in the galactic core. This radiation is crucial for identifying the presence of dust and gas surrounding Sagittarius A asterisk, providing us with information about how stars form and evolve in this region. As we observe closer to the core, we enter the realm of X-ray radiation. This type of radiation is like superlight that reveals the most energetic activities. Astronomers use special telescopes to capture these X-rays, which are emitted by hot, dense gas being drawn toward the black hole. The energy of this gas is so intense that it heats up to millions of degrees and emits bright X-rays. Imagine a pressure cooker that, when heated, starts to release steam. This is how the galactic core functions, with its energy accumulating and being released in the form of radiation. The combination of these different forms of radiation acts like a cosmic puzzle. By putting the pieces together, scientists can obtain a more complete picture of what is happening in the core. But why is it so important to study this radiation? The answer is simple. It helps us understand the dynamics of stars and gas in the core, and how all of this relates to the evolution of the Milky Way. Moreover, radiation also offers us a glimpse into the history of the galactic core. By studying variations in the emission of different types of radiation, astronomers can infer past events such as star mergers or the capture of matter by the black hole. It's like reading a cosmic diary that narrates the adventures and changes in this region of space. However, there is more. Radiation also affects the interstellar medium surrounding the core. Just as the sun warms the Earth, the intense radiation from the galactic core impacts the surrounding gas and dust, influencing the formation of new stars. This process is crucial, as without the energy and materials coming from the core, many stars we see in the sky would never have come into existence. On the other hand, the interaction of radiation with the interstellar medium can also have drastic consequences. It can strip gas clouds of their material, hindering the formation of new stars. In this way, the galactic core acts as a powerful engine of creation and destruction, balancing the life and death of stars in its neighborhood. As scientists continue to study the radiation from the galactic core, intriguing questions arise. For example, how does radiation affect the formation of larger structures within the galaxy? Could the activity of the galactic core influence the formation of nearby galaxies? These questions lead us into a territory where curiosity and research intertwine. And let's not forget that the study of radiation is not just an academic exercise. The technologies and methods developed to observe galactic radiation have had applications in other fields, from medicine to communication technology. So every time astronomers observe the galactic core, they are also contributing to the advancement of science in multiple areas. In summary, the emission of radiation from the galactic core is a multifaceted phenomenon that not only provides us with information about the present and past of our galaxy, but also helps us project our future in the cosmos. By exploring this radiation, we are unraveling the secrets of the Milky Way and, in a broader sense, the universe we inhabit. The quest for knowledge never stops, and each flash of radiation is another step toward understanding our place in the vast and mysterious cosmos. Have you ever wondered how it is possible for a black hole to spit material into space? In the galactic core of our Milky Way, this is not just an extraordinary phenomenon, but a fascinating cosmic spectacle. At the heart of our galaxy, the supermassive black hole known as Sagittarius A** is surrounded by a dynamic and extremely energetic environment. Here, powerful relativistic jets are formed, which are like a stream of water from a pressure hose. But in this case, they are flows of particles traveling at speeds close to the speed of light. Imagine a volcano erupting, where lava and gases are forcefully expelled. The relativistic jets are somewhat similar. But instead of magma, they consist of plasma, a form of matter found at extreme temperatures. This plasma is hurled into space along opposite axes, forming structures that can extend thousands of light years away. But what energy drives these jets? The answer lies in the immense gravitational force of the black hole, which not only absorbs matter, but also uses it to generate energy. Did you know that this energy comes from the matter falling into the black hole? As the material approaches, it heats up due to friction and compression, creating an accretion disk. This disk shines brightly and emits radiation across various wavelengths, from radio to X-rays. It is in this extreme environment that part of that energy is channeled into the jets, propelling them at impressive speeds. Just like a rocket uses fuel to take off, the black hole uses the surrounding matter as its energy source. Relativistic jets are not just an interesting phenomenon. They also have a significant impact on their environment. When these high-energy particles collide with the interstellar medium, they create shock waves that can trigger star formation processes. Thus, although a black hole may seem destructive, its activity can ultimately foster the creation of new stars. It's as if a forest fire, while devastating, could also enrich the soil for the growth of new plants in the future. The interaction between the jets and the interstellar medium is complex and fascinating. The shock waves generated can compress clouds of gas and dust, creating the ideal conditions for stars to form. This raises an intriguing question. To what extent does the black hole influence the life of its galaxy? The answer is not simple, but it is clear that these jets play a crucial role in the dynamics of the galactic core and in the evolution of the Milky Way. Moreover, relativistic jets are one of the reasons why astronomers are so interested in studying the galactic core. Through telescopes that detect different types of radiation such as X-rays and radio waves, scientists can observe these jets and gain valuable insights into the activity of the black hole. Each burst of energy and each movement of particles tells a story about the history and functioning of our galaxy. Imagine that each of these jets is like a kind of messenger carrying information about what is happening in the core of the Milky Way. As astronomers analyze these jets, they can learn more about dark matter and dark energy, two of the greatest mysteries of the universe. Through the light they emit and the interactions they produce in the interstellar medium, the jets offer us a window into the heart of our galaxy. The question arises, what would happen if these jets did not exist? The galactic core could become a much more chaotic place. Without the energy and material they distribute, the balance that allows for the formation of new stars could be disrupted. Thus, jets are not just a scientific curiosity, they are fundamental to the health and future of the Milky Way. The science behind relativistic jets is still a developing field. Researchers continue to explore how they form and how they interact with their environment. Each new observation contributes to a cosmic puzzle that helps us better understand not only our galaxy but also the universe as a whole. Therefore, every time we look up at the sky, we are reminded that in the core of our galaxy, a spectacle is underway full of energy and mystery. Relativistic jets are a reminder of how extremely interconnected everything is in the cosmos. Matter, energy, and gravity work together in a cosmic dance that has been in motion for billions of years. So the next time you gaze at the stars, think of the galactic core and those jets traveling through space, carrying with them a bit of the history and energy of the Milky Way. Each of them is a testament to the power and beauty of the universe in which we live. The intense radiation emanating from the galactic core has a fascinating effect on the interstellar medium surrounding it. Imagine a lighthouse in the middle of darkness. This is how the core of our Milky Way behaves. A source of light and energy that influences everything around it. But what really happens to the gas and dust found in that region? How does this energy affect the formation of new stars? When we talk about the radiation from the core, we refer to a set of energies that come from different astrophysical processes. This set includes X-ray radiation, visible light, and radio wave emissions. Each of these forms of energy acts as a messenger that tells us stories about what is happening in that part of the galaxy. For example, X-rays are like a portrait of the hottest and most dynamic areas, where gas is heated to extreme temperatures due to the influence of the supermassive black hole Sagittarius A*. Radiation not only illuminates but also interacts with the interstellar medium. When this energy encounters gas and dust, it can produce a phenomenon known as ionization. This means that gas atoms lose electrons and become charged particles. But what does this imply in terms of star formation? Ionization can create bubbles of hot gas that, as they expand, push the surrounding material. This push can, in turn, trigger the formation of new stars in adjacent areas. It's as if the galactic core is sending a signal that says, "There's enough energy here, it's time to create something new." As the gas clumps together and cools, it begins to collapse under its own gravity, forming dense clouds that can give rise to stars. However, not everything is that simple. Intense radiation can also have destructive effects. Some gas clouds can be completely stripped of their material, preventing new stars from forming. This resembles a garden where, although some plants receive light and nutrients, others are affected by the shadow of a nearby tree. Moreover, the radiation from the galactic core can influence the chemistry of the interstellar medium. The intense energy can trigger reactions that create new compounds, altering the composition of gas and dust clouds. This is vital because the elements formed in these clouds are the same ones that will eventually be incorporated into new stars and, ultimately, into planetary systems that may harbor life. The connection between radiation and star formation is therefore a continuous cycle of creation and destruction. In this context, an intriguing question arises. Can the radiation from the galactic core be a driving force for the evolution of our galaxy? As the gas becomes ionized and heated, forces are generated that can shape the very structure of the Milky Way. Interactions between hot and cold gas create movement patterns that can influence the distribution of stars and the formation of new systems. It's a delicate balance that keeps our galaxy alive. The influence of radiation is not limited to star creation. It also affects the interstellar medium in a broader sense. The bubbles of hot gas generated by radiation can act as a kind of cleaner in space, removing material that could otherwise contribute to the formation of new stars. This means that while the galactic core is a source of energy and creation, it can also be an agent of destruction. Additionally, we cannot forget the role played by relativistic jets, which are flows of extremely energetic particles that emerge from the supermassive black hole. These jets not only represent a spectacular phenomenon but also provide energy to the interstellar medium. By interacting with the surrounding gas, they can generate shock waves that heat and stir the medium, creating new dynamics in the star formation process. The radiation from the galactic core creates a constantly changing environment. Fluctuations in energy and gas composition can lead to cycles of star formation and destruction that may have been occurring for billions of years. This leads us to wonder, how has this dynamic affected the history of the Milky Way? Every star that is born, every solar system that forms, is a testament to the activity taking place in the galactic core. Astronomers continue to study these processes to unravel the mysteries of our galaxy. Observations of the radiation emanating from the core are crucial for understanding how the interstellar medium behaves and how stars form in this complex environment. Modern tools allow scientists to see beyond the visible, exploring how radiation and gas interact on scales that were previously unimaginable. The future of research in this area is promising as we improve our technology and develop new observational methods. We begin to obtain answers to questions that have remained unanswered for decades. The interaction between the radiation from the galactic core and the interstellar medium is not only a fascinating topic of study, but also offers us a window into the past and future of our galaxy. Finally, it is essential to remember that the galactic core is not just a point of interest in the vast universe. It is an integral part of our history and evolution as a galaxy. The light that emanates from it not only illuminates space but also enlightens us, providing knowledge about the cosmos in which we live. So the next time you look up at the starry sky, think about the bustling galactic core and how its radiation is shaping the Milky Way and life itself. In the vast and mysterious galactic core of the Milky Way, there are fascinating objects known as globular clusters. But what exactly are these clusters and why are they so important for understanding our galaxy? To begin with, imagine a group of bright lights in the darkness of space. Each of those lights is a star, and when they group together compactly, they form what we call a globular cluster. These clusters are like small archipelagos of stars floating in the ocean of space, with hundreds of thousands of stars in a relatively small space. Globular clusters are ancient, much older than our own star, the Sun. They are estimated to be between 10 and 13 billion years old. By observing them, astronomers can peek into the early moments of the formation of the Milky Way. But what do they really tell us about the history of our galaxy? Each cluster is a remnant of the past, a time capsule that allows us to study how stars formed and how the galactic environment evolved. One fascinating aspect of globular clusters is that all their members are practically the same age and composition. This is because they formed from the same cloud of gas and dust. Imagine a group of friends who have been together since childhood. They all share experiences and memories. In the same way, the stars in a globular cluster have had a collective journey through time, allowing scientists to study stellar evolution with great precision. Some wonder, why are there so many globular clusters in the galactic core? The answer is related to gravity. The center of the Milky Way is a place of intense gravitational activity. Gravitational forces pull stars and gas toward the center, favoring the formation of these clusters. In simple terms, it's as if the galactic core were a giant magnet capturing everything around it. Globular clusters are also important because they act as natural laboratories for studying stellar dynamics. Within them, stars interact and move with one another. This allows astronomers to investigate the laws of physics under extreme conditions, where gravity is much stronger than in other parts of the galaxy. How do these interactions affect the lives of stars? Sometimes they can trigger nova explosions, which are like fireworks in the sky. And in other cases, they can lead to the formation of younger stars from the interactions of the old ones. The chemical composition of the stars in globular clusters is another intriguing aspect. These stars are generally poor in metals, meaning they contain fewer heavy elements than younger stars. This characteristic gives us clues about the environment in which they formed. It's as if the stars in these clusters hold a memory of the early days of the universe, a time when there were fewer heavy elements available to form new stars. Understanding the history of globular clusters also helps us better understand the history of the Milky Way as a whole. Each of these clusters may have been part of galactic merger events, where our galaxy joined with others. Imagine a dance where partners intertwine to form new bonds. That's how galaxies interact and evolve. Globular clusters are silent witnesses to those dramatic events. The way globular clusters are distributed around the galactic core is also noteworthy. They are found in a spherical halo around the center of the galaxy, and their arrangement can tell us a lot about the dynamic history of the Milky Way. The closer they are to the core, the more influenced they are by the gravity of the supermassive black hole, Sagittarius A*. This creates an environment where stars can be ripped from their clusters and thrown to other parts of the galaxy. Astronomers use different techniques to study globular clusters. Observations with optical and X-ray telescopes allow them to analyze the light and radiation emitted by these stars. Did you know that by measuring the light they emit, scientists can determine the distance and speed of the clusters? This helps us map the structure of our galaxy more accurately. As scientists study globular clusters, intriguing questions arise. For example, what will happen to them in the future? Over time, some may disintegrate and their stars may disperse into the galaxy, while others may merge with other clusters, forming new structures. The evolution of these clusters is a reminder that in the universe, everything is in constant change. Additionally, research on globular clusters could offer clues about dark matter. By analyzing how stars move within these clusters, astronomers can infer the presence of matter that we cannot see. This is crucial for understanding the total composition of the Milky Way and its structure. Globular clusters, therefore, are more than just groups of stars. They are key pieces in the puzzle of our galaxy. They tell us stories about their formation, evolution, and the environment in which they live. Each cluster is a beacon that illuminates dark parts of our understanding of the cosmos. Finally, exploring the globular clusters in the core of the Milky Way not only allows us to better understand our galaxy, but also connects us to the vast universe. They are reminders that, although we are small compared to the immensity of the cosmos, each star, each cluster, has a story to tell and a role to play in the grand narrative of the universe. The story of our galaxy, the Milky Way, is like a fascinating epic tale that spans billions of years. But what is the first chapter of this story? It all began in a vast sea of gas and cosmic dust. Imagine a blank canvas, where the colors of the universe start to blend. This primordial canvas was filled with the simplest elements like hydrogen and helium, which came together through gravity, forming the first stars. What happened after these stars shone for the first time? Some of them lived short and explosive lives, becoming supernovae that scattered heavy elements throughout space. These elements were crucial as they served as raw material for new generations of stars and planets. Thus, the cycle of stellar life began, and the Milky Way started to take shape. Over time, clusters of stars formed, and these clusters were the first building blocks of our galaxy. As we advance in this cosmic story, we can imagine the Milky Way as a great rotating disk. No, it's not a music disk, but a vast plane where stars spin in harmony. At the center of this disk, the galactic nucleus, lies a supermassive black hole. But how did this mysterious object form? As stars grouped and collided, matter accumulated, creating a gravitational force so intense that nothing could escape from it. Thus, the black hole grew, trapping everything around it. In this journey through time, the Milky Way was not alone. Throughout its history, it has interacted with other galaxies. Some have passed nearby, while others have collided and merged. These collisions have been fundamental to the evolution of the galactic nucleus. Galactic mergers are like unexpected encounters at a cosmic party, where galaxies intertwine and transform. Each collision has left a mark on the structure of our galaxy, creating new spiral arms and reorganizing matter in the nucleus. And what about the stars that inhabit the galactic nucleus? These stars are like the protagonists of our story, each with its own path and destiny. As they orbit the supermassive black hole, they experience extreme gravitational forces. Some come so close that they are worn down, while others manage to escape and continue their course through the galaxy. This delicate balance between attraction and escape is what keeps the stellar dance alive at the center of the Milky Way. As stars are born and die, the galactic nucleus also becomes a place of star formation. Despite the intense gravity and radiation, gas and dust continue to clump together, creating new stars. This process is reminiscent of a concert hall where, despite the noise, some musicians manage to play harmonious melodies. Thus, stellar life continues at the center of our galaxy, driven by the same material that once formed the first stars. Another intriguing aspect of the Milky Way's story is its evolution through the ages. In its early days, the galaxy was a hotbed of activity, with stars being born at a dizzying pace. However, as eons passed, many of these stars exhausted their fuel and became red giants or supernovae. Over time, the rate of star formation decreased and the galaxy began to stabilize. But does this mean that the end is near? Not at all. The Milky Way continues to evolve and its story is far from over. Interaction with other galaxies has also left marks on our history. Some have been consumed by our Milky Way, while others have left their imprint in the form of stars and gas. These mergers and cosmic encounters have contributed to the diversity of our galactic environment. Every star, every cluster, every cloud of gas has a story to tell, and together they form the rich tapestry of the Milky Way. Reflecting on the history of our galaxy, it is fascinating to think about how it has transformed from its formation to the present. The first stars have given way to generations of celestial bodies, and the galactic nucleus has evolved in response to changes in the matter around it. This journey is not only a tale of cosmic events, but also a reminder of the interconnectedness of everything in the universe. The Milky Way is not just a home for us, but also a witness to the endless cycles of birth and death, of collisions and mergers. With every step, it teaches us about the nature of the cosmos and our place within it. By studying its history, we can gain insights into the future, about how it might continue to evolve and what surprises still await us. So, when you look up at the night sky, remember that every star you see is part of this grand narrative. The Milky Way has lived millions of stories, and each one has contributed to the galaxy we know today. In this vast universe, there will always be more to discover, more questions to answer, and more mysteries to unravel. The story of the Milky Way is just the beginning of an endless journey toward knowledge. Galaxies are not lonely islands in the vast ocean of the universe. They are more like large cities full of life and activity, interacting with each other in surprising ways. One of the most fascinating dynamics in the cosmos is how galaxies collide and merge. But what does this really mean for our own Milky Way and its galactic core? When we talk about galactic mergers, it is crucial to understand that this is not a simple crash like one might imagine in a car accident. Galaxies are massive structures composed of stars, gas, dust, and yes, dark matter. When two of these gigantic formations approach each other, their gravitational forces begin to interact. But what happens at that moment? Imagine two clouds of smoke meeting and starting to mix. At first, they may seem to be in a gentle dance, but as they get closer, the shapes distort and transform. Similarly, when galaxies meet, their spiral arms deform and merge in a cosmic spectacle that can last millions of years. As they enter this gravitational dance, the stars in each galaxy do not collide directly due to the enormous distances between them. However, the effect of gravity can destabilize the orbits of the stars, causing some to be thrown into new trajectories. Can you imagine being a star in the midst of this whirlwind? Your journey through space could change forever. The influence of these mergers also extends to the galactic core. When two galaxies unite, their cores, which contain supermassive black holes, may begin to orbit each other. As they get closer, they feed on the surrounding matter and, in the process, can launch jets of energy that illuminate space. This phenomenon is not only fascinating but also vital for understanding how the galactic core of our Milky Way evolves. What happens after the merger? The resulting galaxy is not simply a new home for the stars that were in the original galaxies. The shape it takes may be filled with new star clusters, and the distribution of matter is completely reconfigured. This process can lead to the formation of new stars and planetary systems, as well as the creation of more complex structures within the galaxy. Galactic mergers can also be responsible for bursts of star formation. When gas and dust are compressed due to gravitational forces, a wave of star creation is triggered. Imagine a creativity workshop where suddenly all the available materials come together and start forming new masterpieces. That's how new stars shine in the cosmos. Moreover, these collisions are not unique events. Galaxies can undergo multiple mergers throughout their lives. Each encounter leaves its mark, affecting the structure and dynamics of the galaxy. It is a continuous process, a cycle that repeats over billions of years, where each merger contributes to the evolution of the Milky Way as we know it today. One of the intriguing questions that arise is, what will happen to our galaxy in the future? The Milky Way is on a collision course with the Andromeda Galaxy. This encounter is scheduled to happen in about 4 billion years. While it may sound frightening, the distance between the stars will make it a more spectacular than catastrophic event, resulting in a new galaxy that will be the outcome of this merger. The story of galactic mergers is not only fascinating, but also helps us understand our own cosmic history. Through these interactions, we gain clues about how galaxies form and evolve, and how each of them, including the Milky Way, has been shaped by the universe around us. As we explore the universe, we realize that we are connected in ways we never imagined. Galactic mergers teach us that we are not alone in the cosmos. We are part of a vast network of interactions in which every star, every galaxy, and every black hole has its role to play. So the next time you look up at the starry sky, remember that those lights you see are part of a constantly evolving story. The Milky Way and its galactic core are just a chapter in the great book of the universe, where each merger and each collision are events that shape our cosmic destiny. In this journey, learning never stops, and each discovery brings us a little closer to understanding the magnitude of our place in the universe. The life of a black hole is one of the most fascinating and mysterious in the universe. Let's start by exploring how one of these enigmatic objects forms. When a massive star, which has at least 3 times the mass of the Sun, exhausts its nuclear fuel, it can no longer hold itself against gravity. At that moment, the star collapses in on itself, and in an instant, it becomes a black hole. But what happens after this dramatic event? Black holes are not just static entities, they are dynamic, with an active and constantly evolving life. As the black hole forms, it begins to attract the surrounding matter. Imagine it as a vacuum cleaner in a messy room, sucking everything in its path. This process of feeding is crucial for its growth. The matter falling toward the black hole forms an accretion disk, a kind of whirlwind of gas and dust spinning at high speed. This disk is extremely hot and shines brightly, allowing astronomers to detect the presence of the black hole. But what happens when a black hole feeds? In this process, enormous amounts of energy are released. This energy manifests in the form of radiation, which can be observed by telescopes at various wavelengths. Thus, although a black hole itself does not emit light, its surroundings can be a brilliant spectacle. The bursts of radiation generated can be so powerful that they outshine an entire galaxy. It's as if the black hole is putting on a cosmic light show, but only for those who know where to look. The life of a black hole is not limited to growing and accumulating matter. Over time, some black holes may enter a quieter phase where their feeding rate decreases. This can lead to the black hole becoming a sleeping giant, which, although it may still be extremely massive, is not performing the same dazzling energy display. However, the story of a black hole does not end there. As they continue to interact with their surroundings, they can experience cycles of activity and calm, alternating between moments of veracity and periods of inactivity. Interaction with other stars and black holes can also trigger changes in their evolution. Occasionally, 2 black holes may encounter each other and merge, creating an even larger one. This event is like a cosmic dance where 2 entities intertwine in a spiral of gravity, generating gravitational waves that can be detected here on Earth. The merger of black holes is one of the most exciting phenomena in modern astronomy, as it provides valuable information about the nature of space and time. But what about those black holes that are alone? They can continue to grow in solitude, accumulating matter from their surroundings for millions of years. However, eventually, even black holes can meet their end. Through a process known as Hawking radiation, a black hole can emit particles and slowly lose mass. Although this process is extremely slow and can take billions of years, it serves as a reminder that even black holes, as powerful as they are not eternal. The life cycle of a black hole is a fascinating reminder of the ever-changing nature of the universe. From its birth as the collapse of a giant star to its eventual disappearance, each stage is marked by dynamic interactions and dramatic changes. These cycles show us that the life of a black hole is not limited to its existence in a cosmic void. It is intertwined with the fabric of space and time, affecting the stars and systems that surround it. The life of a black hole is, in many ways, like an epic story full of ups and downs, of growth and solitude. Each black hole has its own path, marked by the matter it consumes and the interactions it has throughout its life. By studying how they grow and evolve, astronomers not only learn about these fascinating objects, but also about the history of galaxies and the universe as a whole. At its core, the life of a black hole is a journey of transformation and discovery. From its formation to its eventual disappearance, each phase is filled with mysteries to solve and questions to answer. Through observation and study, scientists continue to unravel the secrets of these cosmic giants. And each new discovery brings us a little closer to understanding not only black holes, but also ourselves and our place in the vast universe. Human curiosity has led astronomers to develop a series of fascinating tools to explore the universe, and the study of the galactic core is no exception. In this vast cosmos, the core of the Milky Way presents itself as an enigma full of secrets. And to unveil them, scientists have turned to innovative methods that seem straight out of a science fiction movie. But how do we manage to observe what is so far away and so mysterious? Telescopes have evolved enormously since their inception. Instead of simply looking at the stars, astronomers have learned to listen to the different wavelengths of light they emit. For example, radio wave telescopes are like giant antennas that detect radio signals coming from celestial objects. These wavelengths are invisible to the human eye, but they reveal crucial information about the galactic core. Imagine you are listening to a conversation in the middle of a crowd. Those telescopes can isolate a specific voice and understand what is being said, even amid the background noise. Infrared radiation also plays an essential role in this quest. When the dust and gas surrounding the galactic core obscure visible light, infrared radiation acts like a flashlight, allowing astronomers to see through that cosmic fog. This is similar to wearing sunglasses that filter out intense light, letting through only what we need to see. Thanks to this technique, we can observe star formation and interactions at the center of our galaxy, giving us a glimpse into a dynamic and ever-changing world. But what about X-ray telescopes? These devices are like extremely sharp eyes capable of capturing the most energetic light emitted by the universe. In the galactic core, X-rays are a sign of intense activity, such as the presence of supermassive black holes devouring matter. Astronomers use these telescopes to study how matter accelerates and heats up as it approaches these gravitational monsters. Thus, X-ray observation becomes a vital resource for understanding the cosmic dance that occurs around us. Now imagine you are in a huge dark hall and suddenly someone turns on a bright light. That light reveals hidden details that you couldn't see before. Similarly, the combination of different wavelengths from radio to gamma rays allows astronomers to obtain a more complete picture of the galactic core. Each wavelength contributes a piece of the puzzle, and by putting them together, we can have a clearer view of what is really happening at the heart of the Milky Way. Astronomers have also developed computer simulations that help them visualize how stars and gas might behave in the galactic core. These simulations are like models of the universe that allow experimentation with different variables to see how they might affect the evolution of our galaxy. With this tool, they can predict how new stars will form and how black holes will behave, providing invaluable context for actual observations. International collaboration also plays a crucial role in the study of the galactic core. Astronomers from around the world share data and resources, creating a network of knowledge that extends beyond borders. This is comparable to a team of researchers joining forces to solve a complex mystery. Together, they can combine their findings and theories to build a more complete and accurate picture of the galactic core. However, despite all the progress we have made, there is still much to discover. There are questions that continue to challenge scientists. Why does the galactic core emit so much radiation? What underlying processes are at play? Each answer seems to open up more questions. This uncertainty is what drives curiosity and research, leading astronomers to keep searching for answers in the vast cosmos. Technology has not only revolutionized the way we observe the universe, but has also democratized access to this information. Nowadays, anyone with an internet connection can explore images and data from telescopes around the world. This creates a new generation of amateur astronomers who contribute to science and expand our understanding of the galactic core. With each technological advance, our ability to explore and understand the galactic core expands. From cutting-edge telescopes to innovations in data analysis, the tools we use are becoming increasingly sophisticated. However, the essence of astronomical exploration remains the same, a deep desire to understand our place in the universe. As we continue to investigate the galactic core, it becomes evident that each discovery is just one more step in an endless journey. Each new piece of data brings us a little closer to unraveling the mysteries of our galaxy. Deep down, we are explorers seeking answers in the darkness of space, driven by the same curiosity that has led us to look up at the stars since time immemorial. In conclusion, the study of the galactic core is not only fascinating but also essential for our understanding of the universe. The tools and techniques we use are a testament to human innovation and the relentless pursuit of knowledge. As we look to the future, the excitement of discovering the unknown remains a powerful force that drives us to keep exploring. The story of the galactic core is far from over, and each new discovery is another page in the vast epic of the Milky Way. Have you ever stopped to think about the mysteries hidden in the galactic core of our Milky Way? Although astronomers have made enormous strides in understanding it, many questions remain unanswered. As if it were a cosmic puzzle, what secrets does the heart of our galaxy hold? In this section, we will explore some of the most intriguing enigmas surrounding this enigmatic place. One of the most captivating mysteries is the nature of dark matter. While we know it makes up a large part of the universe, its essence remains elusive. What exactly is it? Some scientists describe it as a kind of ghost that we cannot see or touch, but that has a visible gravitational influence. The relationship between dark matter and the galactic core raises even more questions than answers. How does its presence affect the formation and stability of stars in that region? Another fascinating enigma is the behavior of Sagittarius A*, the supermassive black hole at the center of our galaxy. This dark giant seems to possess immense power, but how does it feed? There are theories about how it devours surrounding material, but each discovery generates more questions. Could there be other hidden black holes in the vicinity of Sagittarius A*? The idea that more of these colossi exist in such a small space is both chilling and intriguing. Over the years, astronomers have observed that the stars in the galactic core appear to have chaotic movements. This phenomenon suggests that there are forces at play that we do not yet fully understand. Why do some stars cluster while others seem to move erratically? The dynamics of stars in that region is an active field of study, full of surprises and discoveries. The interactions between stars and the supermassive black hole also raise questions about the nature of time and space. How does the intense gravity of Sagittarius A* affect the light it emits? Theories based on Einstein's relativity suggest that time may behave differently in its proximity, but what does that really mean for us? The idea that time could bend in those proximities is hard to imagine. What about the radiation bursts emanating from the galactic core? These emissions are an impressive spectacle and at the same time a mystery. Why do they occur, and what can they tell us about the processes taking place in that region? Astronomers use different types of telescopes to study these radiations, but each answer seems to open the door to new questions. Could there be forms of life developing in such an extreme environment? The relativistic jets launched from the black hole are another fascinating phenomenon. These jets of matter are propelled at speeds close to the speed of light, but what generates them? The interaction between the black hole and surrounding material could be key. But there is still much to discover. What impact do these jets have on the interstellar medium and on the formation of new stars? An aspect that is often overlooked is the globular clusters in the galactic core. These groupings of ancient stars have stories to tell, but many of them remain a mystery. How did they form, and what can they tell us about the evolution of the Milky Way? Each cluster is like an ancient book, full of tales about our galaxy's past. The very history of the Milky Way is intertwined with these mysteries. From its formation to its evolution over billions of years, there are many questions that still lack answers. How have the galactic core and the spiral arms of the galaxy influenced each other? Studying the core may provide clues about the complete history of our home in the cosmos. Galactic collisions are another intriguing mystery. Mergers between galaxies can be dramatic events that alter the galactic core. What happens when two supermassive black holes meet? Theories suggest they could form a new, even more powerful black hole, but we need more data to confirm these ideas. As we advance in the study of the galactic core, technologies and methods are becoming increasingly sophisticated. However, the question persists: how can we be certain of what we are observing? The search for answers requires a combination of observation, theory, and sometimes a bit of intuition. Could future space missions unveil some of these secrets? In this exciting field of astronomy, researchers face enigmas that challenge our understanding of the universe. Each advance brings new questions, and human curiosity remains the driving force behind this effort. As we delve into the mysteries of the galactic core, we are also exploring the limits of our knowledge and the very nature of the cosmos. So the next time you look up at the starry sky, remember that in the heart of the Milky Way lie secrets we are still trying to unravel. The exploration of the galactic core is not only a journey into the unknown, but also a reflection on our own existence in this vast and mysterious universe. The quest for answers continues, and each discovery brings us a little closer to understanding not only our galaxy, but also the cosmos as a whole. The Milky Way, our home in the cosmos, has a fascinating future that promises to be as intriguing as its history. But what will happen to our galactic core in the coming billions of years? As we look to the future, it is essential to consider how the interactions and processes occurring now will affect the evolution of our galaxy. First, it is interesting to think about how the Milky Way behaves like a living organism. Just as a human body adapts and changes over time, our galaxy is also in constant transformation. Stars are born, live, and eventually die, releasing the elements that will form new generations of stars. This endless cycle is fundamental to understanding how the galactic core will develop in the future. One of the most fascinating aspects is the relationship between the supermassive black hole, Sagittarius A*, and the stars surrounding it. As time goes on, this black hole will continue to accumulate matter from its environment. Imagine a magnet attracting everything that comes near it. With each star that is consumed, the black hole not only becomes more massive, but also influences the dynamics of nearby stars, altering their orbits and behaviors. What will happen when the black hole becomes even more powerful? The future of the stars in the galactic core is another intriguing topic. Over time, the conditions in this region will become increasingly chaotic due to the intense gravity of the black hole. The stars that form in this environment may have unusual trajectories and could even be expelled from the central region, traveling along the galactic disk. Will these stars be the ones that in the distant future illuminate other parts of the galaxy? We cannot forget dark matter, that mysterious substance that makes up a large part of the universe. Its influence on the stability and structure of the galactic core is crucial. As our galaxy evolves, dark matter will continue to play a role in how stars and gas are distributed in the core. Could there be changes in the amount of dark matter? And how would that affect the gravity that holds everything in place? Galactic collisions are also a key factor in the future of the Milky Way. Over time, our galaxy will interact with nearby galaxies, such as Andromeda. This encounter will not only change the shape of our galaxy, but will also affect the galactic core. Galactic mergers can trigger intense star formation in the core, creating a vibrant and active environment. What kind of cosmic spectacle could arise from these collisions? Moreover, the radiation emitted by the supermassive black hole will continue to affect the interstellar medium in which it resides. The intense energy released could modify conditions, favoring or inhibiting the formation of new stars. What will the landscape of the galactic core look like under the influence of this radiation? In the realm of globular clusters, these groups of ancient stars will also tell their own story in the future of the Milky Way. As the galactic core evolves, some of these clusters may be stripped and dispersed, while others may merge with the core, bringing their own history and elements to the mix. What secrets of galactic history will be revealed as these clusters interact? Life in space is an endless cycle of creation and destruction. As stars die, they release their remnants into the interstellar medium, where they clump together and form new stars. This cyclical process not only nourishes the galactic core, but also establishes a balance in the system. What will happen when this balance is disrupted by unpredictable cosmic events? The quest for answers about the future of the Milky Way is also driven by scientific observations. Astronomers continue to develop advanced technologies to study our galactic core and its surroundings. With each new discovery, more questions arise about what lies ahead. What mysteries of the universe will be unveiled in the coming years? Finally, it is important to remember that just as the past of the Milky Way is filled with dramatic events, its future also promises to be spectacular. Each of the decisions and processes occurring now will influence the fate of our galaxy on unimaginable timescales. Understanding these phenomena will not only help us better know our galaxy, but will also provide us with a broader insight into how the universe as a whole functions. The future of the Milky Way, and particularly its galactic core, is a topic that invites reflection. The combination of dynamic processes, galactic interactions, and the eternal struggle for existence between stars and black holes reminds us that the cosmos is a place of constant change. As we continue to explore our universe, each new discovery brings us a little closer to unraveling the mystery of our place within it. Undoubtedly, the future of the Milky Way will be an exciting story yet to be written. The Milky Way, our cosmic home, is just one of the billions of galaxies in the universe. But have you ever wondered what makes it special compared to other nearby galaxies? As we look into space, we encounter a fascinating puzzle of galactic structures, each with its own core and unique characteristics. Comparing our galactic core with others can provide us with valuable clues about our own history and the evolution of the cosmos. Let's start by talking about Andromeda, our closest galactic neighbor. Andromeda, like the Milky Way, harbors a supermassive black hole at its center. However, its black hole is considerably larger than Sagittarius A*, our own. This raises an intriguing question. What does this mean for the dynamics of Andromeda? The answer may lie in how galaxies grow and feed on their surroundings. Andromeda, with a more massive center, might be absorbing more matter, which in turn could influence the type of stars that form around it. On the other hand, we observe M33, the Triangulum galaxy, which is smaller and less massive than the Milky Way. In its core, the supermassive black hole is much less prominent. What does this tell us about its formation? It is possible that M33 had a quieter start, allowing it to form a more uniform stellar population. By comparing its core with ours, we can infer that the evolutionary history of a galaxy may be linked to the mass of its central black hole. But not all galaxies are the same. The Sombrero galaxy, with its bright core, presents a curious phenomenon. Its black hole is also supermassive, but the environment surrounding it is completely different. The way stars are distributed in its core is denser, which may generate more intense stellar activity. Could this imply that galaxies with more active cores tend to have shorter stellar lifespans? The answer to this question could offer clues about the life and death of stars in different galactic environments. As we explore further, we find elliptical galaxies, which are distinct from spirals like the Milky Way. In these galaxies, the core can be extremely dense and lack the spiral structure we know. The absence of spiral arms raises the question of how stars and gas are distributed within. Why do some galaxies appear more chaotic than others? The answer may be related to the tumultuous past of each galaxy, including mergers and collisions with other galaxies. Speaking of collisions, let's observe how these interactions affect galactic cores. The Antenna Galaxy, for example, is the result of two merging galaxies. The activity in its core is frantic, with new stars forming at a dizzying pace. This leads us to wonder, what happens to the core of a galaxy when it gets caught in the chaos of a collision? Studies suggest that these events can trigger a burst of star formation, leading to a dynamic and vibrant core. When observing distant galaxies, astronomers often encounter cores that emit intense radiation, suggesting the presence of supermassive black holes that are devouring matter. This makes us wonder, how do these active cores influence the evolution of their host galaxies? The radiation and energy released can have profound effects on the interstellar medium, affecting the formation of new stars and the dynamics of neighboring galaxies. One of the most intriguing questions is how the galactic core of the Milky Way compares to those of other galaxies in terms of activity. Some cores are true star-making factories, while others seem to be in a state of calm. This could indicate that the history of each galaxy is marked by its environment and evolutionary history. In the Milky Way, the balance between the black hole and the stars surrounding it appears to be essential for maintaining stability. Observations of other galaxies have also allowed us to make interesting connections. For example, the globular clusters in the core of the Milky Way are a testament to its history. By comparing these clusters with those in other galaxies, we can deduce how they formed and evolved over time. It is fascinating to think that each globular cluster may be a fragment of the galaxy's history, a record of past events that helps us understand the present. As we delve deeper into the comparison, the question arises of whether the galactic core of the Milky Way is typical or unusual. The answer is not straightforward. Some galaxies exhibit similar cores, while others reveal unique characteristics. This suggests that there is no one-size-fits-all model. Rather, each galaxy has its own narrative. The importance of studying these galactic cores lies in the broader insight they offer into how galaxies behave in the universe. Through comparison, we can unravel the secrets of our own galaxy and how it fits into the cosmic fabric. What lessons can we learn from Andromeda, M33, or the Sombrero Galaxy? Each of these galaxies has stories to tell, and by listening to them, we can better understand our place in the cosmos. In conclusion, by exploring and comparing the galactic core of the Milky Way with other galaxies, we discover not only the diversity of the universe, but also the uniqueness of our own galaxy. Each galactic core is a mirror reflecting the history and evolution of its environment. So the next time you gaze at the starry sky, remember that each star and each galaxy has its own story to tell, and that by learning about them, we are also learning about ourselves and our place in the vast universe. In the vast universe that surrounds us, understanding our own galaxy, the Milky Way, is fundamental to unraveling the mysteries of the cosmos. But why is the galactic core so important in this context? This space, so dense and energetic, not only houses a supermassive black hole, but also plays a crucial role in the evolution and stability of our galaxy. By exploring its influence, we can better understand how galaxies form, how they interact with each other, and how the universe behaves as a whole. The galactic core acts as a mirror in which we can observe the history and dynamics of the Milky Way. By studying its structure and composition, astronomers can gain clues about the behavior of other galaxies. Imagine you are in a vast cosmic library where each book represents a galaxy. The galactic core of our Milky Way is like an open book that reveals secrets about the formation and development of its contents. This core is not only fascinating in itself, but also serves as a benchmark for cosmology in general. Dark matter, that enigma that makes up most of the universe's mass, plays a fundamental role in the stability of the galactic core. Without it, the structure of the Milky Way would be very different. Just as an architect needs a blueprint to build a solid building, astronomers rely on dark matter to understand how our galaxy stays bound together. Have you ever wondered how something so intangible can affect something so tangible? The answer lies in its gravitational influence, which helps maintain balance in the galactic core. But what about the supermassive black hole? Sagittarius A*. This cosmic monster is the beating heart of our galaxy. Its gravitational influence not only affects the stars that orbit around it, but also has a significant impact on the formation of new stars. When black holes are mentioned, they are often thought of as dark and terrifying, but in reality, they are fundamental to galactic dynamics. Like a bright star that draws attention, Sagittarius A* attracts matter around it, influencing the galactic environment in surprising ways. One fascinating aspect of the galactic core is how stars behave in such a dense region. Imagine a massive cosmic dance where stars swirl and twirl around a supermassive black hole. This movement is not random, it is governed by gravity. Stars that are closer to the core experience intense gravitational forces, allowing them to move at dizzying speeds. The interaction of these stars also provides clues about the history of the galactic core. Isn't it amazing to think that the movement of these stars can tell such a rich and complex story? The process of star formation in the galactic core is another point of interest. In such an extreme environment, clouds of gas and dust clump together and collapse, giving birth to new stars. This process is like a cosmic life cycle where the death of one star can lead to the life of another. The intense activity in the galactic core provides a natural laboratory for studying how stars form under extreme conditions. Can you imagine what it would be like to see a star being born amidst that cosmic chaos? The radiation emitted by the galactic core is also a fascinating topic. Different types of radiation, from radio waves to X-rays, offer astronomers a window into the behavior of this region. Each type of radiation tells part of the story, helping scientists understand how material behaves in the environment of the black hole. Isn't it incredible to think that through radiation, we can gain information from such a distant place? The relativistic jets emanating from Sagittarius A* are another intriguing phenomenon. These jets of particles travel at speeds close to that of light, and their impact on the galactic medium is significant. Imagine a powerful jet of water shooting out of a hose. That's how powerful these jets are, sculpting the space around them and feeding the interstellar medium. The energy they release can influence the formation of new stars and the evolution of gas and dust in the galaxy. In this sense, the intense radiation from the core not only affects stars but also the interstellar medium. The radiation can ionize the surrounding gas, influencing the formation of new stars and the chemistry of the galactic medium. It's as if the galactic core has a direct impact on the climate of the space around it. Have you ever wondered how the environment of a galaxy can affect the creation of new stars? Globular clusters, those groups of ancient stars that orbit the galactic core, are key pieces in this puzzle. These clusters act as cosmic fossils, preserving the history of the Milky Way. By studying their composition and distribution, astronomers can unravel the history of our galaxy's formation. Can you imagine how many secrets these clusters have witnessed over billions of years? The history of our galaxy is a tale of transformation and evolution, where the galactic core has played a central role. From its origins as a collection of gas and dust to becoming the complex system we know today, each stage has been influenced by the dynamics of the core. This journey through time gives us a new perspective on our existence in the universe. Who are we really in the vast cosmic stage? Galactic collisions also play a role in the history of the core. These mergers between galaxies not only reshape their structures but can also trigger the formation of new stars in the core. Imagine two rivers meeting and creating a new channel. That's what happens when galaxies collide. Each collision brings new opportunities for growth and evolution. Isn't it fascinating to think about how our galactic interactions can lead to new forms of stellar life? Modern technology has allowed astronomers to study the galactic core with unprecedented detail. From radio wave telescopes to X-ray observatories, each tool provides a new perspective on this enigmatic region. These observations are like a map guiding us through the mysteries of the galactic core. How many secrets still await us, hidden in the glow of the cosmos? As we delve into the current mysteries of the galactic core, curiosity intensifies. There are unanswered questions that continue to challenge scientists. What will happen to Sagittarius A** in the future? How will its evolution affect the Milky Way? Each answer opens the door to new inquiries. And that is the essence of scientific exploration. The future of the Milky Way, influenced by the galactic core, is an exciting topic. As the universe evolves, our galaxy will also change. Projections about its evolution lead us to reflect on our place in the cosmos. What will our galaxy look like in billions of years? The answers to these questions will help us understand not only the Milky Way but also the very nature of the universe. Comparing the galactic core of the Milky Way with other nearby galactic cores gives us a broader perspective. Each galaxy has its own story to tell, and by studying them, we can learn about the diversity of galactic processes. These comparisons are like searching for similarities and differences among the cultures of the world. Each has its own traditions, but all are part of the same humanity. Finally, the importance of the galactic core in cosmology cannot be underestimated. By studying this heart of the Milky Way, we not only gain a better understanding of our galaxy, but also contribute to the understanding of the universe as a whole. Each discovery in the galactic core is a brick that builds human knowledge about the cosmos. So as we continue to explore and question, let us remember that each answer brings us a little closer to the truth of the universe in which we live. The vast universe that surrounds us is a place full of mysteries and wonders, and the galactic core of the Milky Way is one of those places where curiosity and science intertwine in a fascinating way. Why is it so crucial to study this region of our galaxy? The answer lies in the key it represents for understanding not only the Milky Way but the workings of the cosmos as a whole. Let's begin to reflect on how the galactic core is a bit like the heart of a great city. In this heart, energy, movement, and above all, a history that reveals how everything around us has formed is concentrated. Just like a city that grows and evolves over time, the core of our galaxy has witnessed extraordinary events that have shaped its structure and dynamics. What secrets does this bustling center of cosmic activity hide? The light emitted by the galactic core, although intense and sometimes dazzling, is only an indication of what occurs there. The radiation emanating from this region is not only fascinating but also provides clues about the processes that govern the universe. By studying this radiation, astronomers can unravel the history of stars and black holes, as well as the influence of dark matter on the formation of our galaxy. But what does this mean for us? It gives us a window into the past and future of our existence in the cosmos. The interaction between stars and the supermassive black hole known as Sagittarius A* is a spectacle worth observing. Imagine a cosmic dance where stars spin and move under the powerful gravitational pull of this dark giant. How does this affect our galactic environment? Each star that orbits around Sagittarius A* is like a piece of a puzzle that helps astronomers understand not only the structure of the core but also the history of the Milky Way as a whole. The study of star clusters in the core is another essential piece of this puzzle. These clusters are like time capsules that contain information about the early stages of the galaxy. By analyzing them, we can glimpse how the Milky Way formed and how it has evolved over billions of years. But what will these clusters tell us about our own future? Ongoing research on the galactic core leads us to intriguing questions about the nature of black holes and their role in the evolution of galaxies. The life of a black hole is a fascinating tale of growth and transformation. As they attract matter, they feed and grow, revealing secrets about how they form and how they influence their surroundings. Could it be that these dark colossi hold the keys to understanding life itself in the universe? As we delve into the radiation emitted by the core, we discover that it not only affects nearby stars, but also the interstellar medium where new stars can be born. The intense energy emanating from this hot and active region is like a cosmic beacon guiding the formation of new generations of stars. What kind of stories could these new stars tell if they could speak? Comparing the galactic core of the Milky Way with other cores in nearby galaxies offers us a broader perspective. By observing how other cores behave, we can better understand our own galaxy and its place in the universe. Each galaxy is unique, but at the same time there are patterns that repeat. What do these similarities and differences teach us about the evolution of the universe? As we approach the conclusion of our exploration, it is important to reflect on how the study of the galactic core not only helps us understand the Milky Way, but also unravels the deeper mysteries of cosmology. Each discovery in this region brings us one step closer to understanding our place in the vast cosmos. In the coming billions of years, the galactic core will continue to evolve just like us. The Milky Way will be influenced by collisions and mergers with other galaxies, and the life cycle of black holes will continue its course. What revelations await us in the future? The story of our galaxy is a tale that continues to be written, and the galactic core is its most intriguing chapter. Human curiosity has led us to explore the unknown, and every answer we find opens the door to new questions. Are we ready to face those mysteries and discover what the universe has in store for us? With every technological advance and every observation, we are getting closer to unraveling the secrets hidden in the galactic core. The importance of continuing to investigate and learn about this region is fundamental, not only for our understanding of the Milky Way, but for our connection to the cosmos as a whole. Thus, the exploration of the galactic core invites us to dream, to question, and to marvel at the greatness of the universe. Every star, every black hole, every flash of radiation reminds us that we are part of something much larger. Although the journey of knowledge can be long and filled with questions, it is precisely that search that defines us as human beings. Are you ready to join this cosmic adventure?